welcome to today's presentation on Power Up Your Cold Rolled with the PowerPack. My name is John Bennett, and obviously I work for Graitec as a Customer Success Manager. So a little bit about my background quickly. So I've been involved in steel fabrication for a very long time. I've been using advanced steel for 20 years now. Spent the last probably 8 years of that, 8 or 9 years working in the channel helping people with advanced steel. Led me to go and work for Autodesk as well. Came back to Graitec as a customer success manager, so I tend to deal with the sort of customizing the system, trying to work out development projects, etc. nowadays, and work alongside my colleagues inside the advanced steel team here within Graitec. So today's presentation is obviously about cold rolled and light gauge metal. Sometimes it's termed in different countries, and we're going to talk some of the tools from advanced steel, some of the enhancements that we've added into the PowerPack, talking through additional tools, also additional drawing processes, bill of materials, etc., and a few tips and tricks along the way. So the first section we're going to talk about is a little bit about Graitec, just to give you a bit of an introduction very quickly. We'll just go through this. For those of you who don't know us, we've been around for quite a while now. We've seen exceptional growth, I would say, in the last 4 or 5 years. The staff number keeps going up. I think it's well over 550 now. We have, I think it's about 300 plus. I think I have another slide that shows that in the development side as well. We have about 100. I think technical side's well over 300, and we have lots and lots of customers, as you can see from the slide there in front of us today. A little bit of an explanation of our geo. So we're predominantly started in France, and obviously a very heavy sort of presence inside Europe. We do expand across obviously into America and other parts of the world, and we do obviously use resellers as well to sell our own products, as well as work alongside them with Autodesk products as well. And I knew there was a figure there. It's just 355 of those people are technical, so they're people like myself, Rob and Alec at a local level that deal directly with clients, etc., offering support and help. So a little bit about our story, so to speak. Obviously we have tools now available to us that enable us to create elements, so that's elements for design. We enhance the Autodesk products with our PowerPacks. We simulate using our own products. Advanced design would be that. We have our own sort of fabrication workshop tool as well, and then we have our own data management source now, which collaborates documentation, file naming, etc., to putting those into a common data environment. So we're trying to doing a very broad spectrum there very quickly, but we're trying to cover all the different bases of the workflow from basically the start to the finish of a project. So to expand upon that, obviously you have the Autodesk portfolio at the bottom there, which is the create element. And then the next element is obviously simulate. So typically you would have a design tool. You can use an Autodesk one as well. Robot structure analysis is also available, but we have our own simulation tools, as they term them these days. Our fabricate tools is obviously based on the backbone of advanced steel. For those of you watching today, probably familiar with that. Armor Plus and Workshop enable us to branch into areas there to do with sort of managing those elements of the process. And then the data element is obviously our own product, OpenTree, which is a file naming sort of common data environment at a local level. So that's working within your company based on a local server. And that does give you the opportunity to work with the top end sort of Autodesk product, which is the BIM 360 Docs environment, which is more of a cloud-based, web-based solution used by larger contractors, larger fabricators, etc. And obviously one of the tools we're talking about today is obviously the PowerPack. We've got tools and additional features in there to enable you to add connection types in, create documentation, even explode the model out to be a solid, etc. Some of the sort of more familiar things that people ask questions about, we end up doing in there and providing that to our customers who are maintained. And I think other people can purchase it well via various web portals, etc. Sorry about all the promo here, but just a little promo for us. Obviously, we're running a series of webinars recently. We did one the other week, I think, was just to do with managing your models. Obviously, the cold one today. We've got the diagnostic and resolving numbering issues. That's always a hot topic, that one. Working with special parts as well, coming up in April as well. Best practices for drawings. Custom model templates, again, that can be quite important if you're trying to set up your model to get your base sort of right before you start working with it. And we do have an events page which has all our various webinars listed on there for other subjects as well. And when we've done all these things, we tend to now put them on an Advanced Steel content portal, which there's a hyperlink on this page. So if you've got the PDF, you'll be able to access that. So all our webinars, tutorials, stuff like that get put on that page that people can access that at any time and go back and request a copy of a recording or download a documentation, etc. So we're trying to make it easier for people to find this stuff after we've done it as well. And obviously there's our blog. So if you subscribe to our blog, you'll see Rob and Alec are very active on there. I do occasionally get on there myself, not so much recently, but the guys are always putting little tips and bits and pieces out there. So moving on into the main topic of today is obviously working with cold rolled and some of the basic features of cold rolled, which I thought I'd sort of mention some of the fundamentals and then some of the improvements that we've done in the PowerPack with just a couple of joints, to be honest, where we've redeveloped them, and obviously some additional suppliers that we provide through those systems. So the first bit I wanted to talk to you about was the structural element macro itself. So this is actually the macro used to place purlins and rails inside Advanced Steel. So we use this. It's a basic tool provided by Autodesk. It comes as part of the system, so anybody can access it. It's not exclusive to the PowerPack. So we can use that to put in and place the purlins to set measurements and eaves beams, etc. And it's one of the number of tools that are available within the standard system. A couple of years back now, I think, last year, I think I actually did a knowledge network page on the Autodesk site because there was always lots of questions about what to do things, how to do things. So I'd, over the years, generated a number of videos, etc. for people. So I took those and put them all under the knowledge network article. Put a hyperlink in the page, but you should be able to find it if you just type in what it says at the top there, cold rolled and light gauge metal purlins, and put my name against it. You should be able to get to it via Google, so you don't need to know all the knowledge network system to find it. And anybody can access it. You don't have to be registered. You can just go in there and access it. And there's a number of videos in there where I'll sort of walk through the operation of a couple of the basic tools available in Advanced Steel that people don't probably even realize that are there. They can be sort of hidden away a little bit. So that was hopefully a good pointer start for 10 there. So to come back to the structural element macro, we're actually going to sort of do a little bit of a walk through that. And one of the things that comes up quite a few times on support and stuff is how do you actually start this thing and position your purlins, and more importantly, the eaves beams always seems a bit of a challenge to people. So I'm just going to walk through this video here today. So it should play. So obviously it's just a simple portal frame that we've created inside the system. And basically what I'm going to do is I'm going to go and use the tool which is found on the main ribbon at the top under the structural elements, and I'm going to apply some purlins to the roof, and then I'm going to position the actual eaves beam. So it's just a straightforward portal macro. So for those of you familiar with that, that is actually a structural element macro as well. Typically used obviously to do a portal. There is a mono portal as well. So here we're going to go to the one up the top here that says purlins, and it can be used for rails as well. It's not exclusive for purlins. Typically I tend to start on the left hand side of a building and at the left hand end, and sort of I'm working from the left hand end to the right, selecting the rafters in turn, or the columns as the case may be. It will ask you for a reference point. Now that does apply quite importantly. Sometimes if you want to start on a column, you'd put it at the bottom. If it was me, I normally set my rails out from the bottom. I have seen people set purlins out or change the reference point. Typically it does work from the top, but you can set out from the bottom. If you don't tell it anything, it will work from the top. If you do tell it something, it will work from that point that you've selected. So I'm actually going to go and pick the top just to force it to work from the top actually. And then what that does, it then prompts to the next one. This catches everyone out, the additional reference beam. And actually what you need to do is go yes to this always, literally, if you want to position the eaves beam, and you need to select a column. And this gives it a face to work to. And this really does help with positioning the eaves beam. Obviously you don't need to do this in the side rails, if we're just putting side rails on. But typically always remember that. And then you'll find that something will appear in front of you. Now, it does depend on which country you're in as to what you'll get. In the North American countries, in other parts of the world, they tend to get hot rolled channels, etc. But in the UK, it is preference to go to a particular supplier. You can change from that supplier. So obviously that's what I'm doing here. I'm using a different supplier and selecting a different section. So here you're actually accessing the profiles database inside the system. And similarly with the eaves beam, you can obviously create it or not create it, depending on if you need it. And obviously then as soon as you activate it with this dialog, you can then access the properties dialog again for the drop down to get to the right supplier. Now there's a couple of other bits in here. There's one there, obviously you can see as a negative angle. That's the other little quirk of eaves beams in advanced steel. They all tend to come at a set angle. That's obviously because it's a fixed profile, so you'll find the libraries for those are quite extensive. Minus normally means it's a negative, so it's going downwards. I have seen that being used, but obviously sometimes, and mainly they're sort of positive, so we'll probably change that. We'll change that to a positive angle at the moment. So you try and find one that's pretty close to your roof pitch that you would use, commonly sort of 6 to 10 degrees, I would have imagined in most cases in this country. I tend to leave it set to beam, so it's above that. I do tend to also keep the eaves beam vertical, although you can uncheck that, but it will go at the incline of the roof then. So I tend to leave it ticked. And I tend to always put the axis on the top left, so it's on the outer corner, so I get into basically the springing point for the actual roof line of the purlins. Now you notice there's a couple of dimensional boxes below that, which you can use, and also you can, if you want to, invert the section. I have seen that used. I have seen that done by people, not in this country, but I have seen it done elsewhere in the world. Obviously the horizontal and vertical, the horizontal is pretty obvious. It's from the column face, which you used the reference beam earlier on to select. Obviously the vertical offset can be a little bit more tricky to work out where it is actually working from. So if we set those both back to 0, you can see the column is now snapped back to the face. The purlin is now snapped back on the face of the column, sorry. So with that, obviously normally you know what the sheeting line is to get out. So normally for a standard supplier using a standard cleat, they'd have a standard gap distance on the bottom of the purlin. So in this case, 207 mil. You can type in a figure and it'll move it over. Now it does depend on the supplier what that measurement is. And obviously the vertical offset, you can see that it sort of moved it, but it's still not in the right place. Now, the trick that I use is I just use my coordinate system and I set it to basically be in the plane there, and then I end up drawing a couple of lines. To be honest, this is the only way I've found to do this efficiently since the macro was first introduced. And I normally use the purlins that I've set on the roof, and I just snap to those to get the basic line. So you can draw the line anywhere or not have it drawn at all, and just use the purlins and the endpoints to snap to. And then, to be honest, I will use some form of a trim stroke extend tool. I mean, I'm just happen to be using the one off the Advanced Steel tool palette here. There's probably 500 different ways to do that. I'm not going to get into that. So, but I will just use that one. I will just set my coordinate system there as well, and I'm going to move that there and put it on the edge of the flange so I can see it in the view, so you guys can see it. And then I'm just using the extend tool. I'm just sectioning the line, the boundary line, etc. So doing that, and that gives me the point that I need. And then obviously I can use the measure tool to get this. Now, obviously, if you've got a common roof across a portal, which does happen, sometimes they're not the same, but if they are, you can actually set it on one side and then actually, because this is a joint, use that on the other side of the roof as well. So I'm just measuring the distance there, and obviously we've got a distance measure for where it should be. So I'm going to go in and go into the joint properties here again. and we're going to play around with the eaves beam and the vertical offset figure, and we're going to see what happens. Now, obviously, if you put a figure in, something will happen, it will move. So that moved in a positive direction, which is in the Z vertical upwards. So obviously, we need to go down in a negative direction, so we put a minus sign in here, and it will drop down. So again, there's a few other things. You can change the model role if you so wish, but I tend to leave it as that for the UK at least. It might be different in other countries. I might want to change it. That one always catches people out, so I normally try and show that when I'm training people as well, how to set these out. Once you've done that, you've got a template. You can then use create by template or joint copy, depending on which country you're in, and actually copy it over to the other side of the portal frame. So one of the next bits I really wanted to talk about was obviously the PowerPack tools. A lot of the standard tools have been talked about before, but obviously Graitec sort of decided to do a few PowerPack tools for this. And we've invested ourselves in these. No one's actually paying us to do these. It's just what we're giving back to our clients. So we've actually put a couple of these tools in place inside the system. And first of all is where to find them. In 2020, we changed to a palette style connection vault. So you'll need to look for them there. So basically you activate it and it comes up on a palette, and there is a tab for them. We also have a supplier ribbon panel as well. So we created a separate panel to pull out the suppliers that we've actually worked with recently, who've given us access to their data, and we've done a project with them to actually include their data into the system. So these are suppliers that are not included in the core Advanced Steel. Graitec has built the data set for them of all their profiles. We've then created all the joint entries that work with the standard joints in Advanced Steel and also PowerPack joints as well. And we decided that we'd put a little panel on so that people could actually see who these were, which is obviously, I think the three we're working with at the moment is Steadman's, Thomas Panels, and Steel Sections. So you should be able to just access that, and that'll give you a quick access straight into it by pressing that button. And obviously just look for the joints on the palette. That was the big change in 2020, as we got our own sort of PowerPack connection vault, which is similar to the Advanced Steel connection vault, and where we've grouped all our different tools available in the PowerPack for users to find. So our other big change to talk about a couple of main tools is our single and double purling joint. We've combined the single and double purling joints into one. This is one joint that will do that, so you can do a single purling or double. And also we have another one as well, which is obviously some advantages on the haunch. We can actually take the stays down into the haunch, which you can't do in a standard joint. Also, we re-looked at the non-continuous purling joint because that was always causing a bit of trouble. So we looked at that and the options available for that, and stays, custom plate brackets, etc., cleat brackets, standard, and also working with standard custom settings available as well from people. So again, those are the two main joints that we've worked up in the last few years, and these joints are working quite well now. So that's what I'm going to go on to expand upon within the next slide, where I'm going to run through a little walk through these, a little video that I've created, and I'm going to talk around that and the use and operation of those tools from the PowerPack. Again, they're found on the PowerPack connection vault under the cold rolled ribbon tab there. There's a button on that, remember from the previous slide. So we're gonna have a look at this. So again, this is just a very basic test model that we have for Advanced Steel. It's probably one of the ones where I was checking the joint out. And I'm going to sort of look here. I've got the ribbon up. And first of all, I'm probably going to talk about creating a section. So this was to go to the cold rolled sections available under the cold rolled panel on the PowerPack ribbon and just draw in a particular section that was available. So here you can see the panels labeled there, and I'm just going to go and pick one in the middle. Obviously, I've gone to this particular supplier if I want, or I could change to a different one. So it will tell you the name. We tried to do a representation of their icon, which is quite difficult to get onto a button, to be honest. So working with one of these, this is how you can draw a section manually. So if you don't use the macro to put them in, you can actually draw manual sections, and it will go in straight into their library. So it's like drawing an I-beam and going to the I-beam, but it's like preference to go to a particular supplier in this case. So this has come up obviously with Thomas panels in the list here, and it's gone straight into their Z profile that's in the system, and it then filters it down just to show those particular sections. So you're within that range, that profile from that supplier, and then you get the different size beams in there. So this is not provided by the core Advanced Steel, it only comes via the PowerPack. We add it in. One of the things you might have to do is you might have to go and find it, which can be a bit of a problem because it's not inside the preference system of Advanced Steel, but you can adjust that yourself. You can go in and do that via the management tool system as well. So I'm just going to take a look at that in here. So for those of you not familiar with this, this is the preference system of Advanced Steel. You can come in and you can change the preference profile by adding a supplier or a different section type in. And in this case, I'm going to add Thomas panels as an example in here. And with them added into the sort of lower half of the system, I'm also adding in steel sections there because they're not included. Stedman's already existed inside Advanced Steel before. We've just updated their profile range. So with that, when you next go back in, if you wanted to draw a section, you should see it actually in the front end of the list. So if you wanted to change, rather than going to the all category, it will come into the preferred sections available. So we're just going to go back in and take another look at that after updating and reloading the defaults, etc. So we can now see that Thomas panels and steel sections are preferred in the preferred list, not under the all category. So that's how you sort of access the individual sort of families. It's probably another term from Revit, really, to be honest, but the section library for a particular supplier. Similarly, obviously, you come back to the structural element purlin macro and rail macro. You have a similar sort of thing where you have to add it into the GUI, which we obviously do via the PowerPack. So we've added those in so that those sections actually exist within the GUI. If we don't add them in, you won't be able to see them inside the macro. So that's done when the PowerPack is installed. Again, they might not come up in the preference list. You might have to go and find them, but you should be able to come in here and see them and change them. And normally what I would recommend is probably once you work with a supplier is maybe create a basic library entry for yourself so you can quickly access the library and change to your supplier. I know fabricators, I know we used to prefer a couple of those that we worked with on a regular basis. So the next thing is obviously the connection vault from the PowerPack. So obviously that's a button on the ribbon at the top, and that obviously turns a palette on, which is very similar to the other palettes that you see inside Advanced Steel. It's based on the same technology. So we have a button for cold rolled at the bottom, and then we have two joints there that we're currently working with that are currently up to date. So we're going to take a look at what we've called the purlin connection, but obviously it can be used for rails as well. And we also will look at the non-continuous purling as well in due course. So again, you sort of follow the prompts. Now this joint can be used in a singular operation and also a double operation. So we're going to look at the singular operation first of all. So with that, obviously I selected the rafter and then the purlin itself, and then applies a joint. Now it will put something on the end to a library entry. And it comes up with a little note as well. It says if there's a non-standard offset. So suppliers tend to have a standard gap from the underside of the purlin to the top of the rafter. And to be honest, I deliberately put this in different to what that gap should be. And it obviously highlights that we're actually doing that. So it's not, some of them are 7 mil, some are 6, some are 10. And it works out with their standard cleats. So if you do anything non-standard, then it will show up. And that does happen where sometimes you get a curved roof and the purlins are going on the curve, but the rafter's actually drawn straight. I have seen that, and obviously we have obviously a series varying different cleats as it goes up and across the roof. So the important thing to remember here is you come into the library tab, you need to select non-catalog. Now it will have a couple of standard entries in there, but if you activate the non-catalog button, that enables you to come in and change the joint type. So here we're going to put an overhang type on. So this is just a straightforward extension where you can put an overhang length on. You can have a stub arrangement, I think, as well. So this is fairly similar to what we've seen in the other ones. And obviously you can change the length of that depending on the length of the cantilever required. Again, all the standard operation, you can put stays in both sides, single side if you want. You can come in and start accessing the parameters here if you so wish. And again, you can create your own entry if you have your own particular requirement for stay plates. Like you always do them at a set size with a set notch, corner removal, etc. You can come in and change those. And again, these joints work with the joint copy singular and multiple options, which I'm just doing here to copy them up the rafter and purlin interface. So we're going to move on now, and we're going to use the same joint to do a double purlin. So you don't have to use a different type of joint. It's the same button. You just press it and you just follow the prompts and select the various input elements which are shown at the command line. Also, we have a nice little feature here. We can select the haunch, and we can do this if we so wish to actually introduce the stays down into the haunch, which cannot be done within the other macros available in the system. This is only available via the PowerPack. Again, it will come to a library entry that's been entered, but you can, as soon as you tick non-catalog, which is very key to this, you can come in and start changing this. So in this case, obviously, I'm going to turn the stays on just to show them going down. And then I come to the second tab where I'm going to adjust where the plate is, and I'm going to say relative to haunch. And then I'll move it down into the bottom of the flange of the haunch. Now, obviously, there's a bit of a clash there, which might occur. You might get that happen, so you'd obviously make some adjustment. You can obviously move the purlin up and down. So to move the purlin up and down, you would come back into the purlin macro and just to change the spacings in that. So again, you're trying to use a combination of tools here together to actually achieve the overall layout. Purlins you can move individually, or you can change the setting out. There is an offset button for an individual purlin, or you can actually just change the setting out figure at the beginning here. I think I'm going to just mess around with that and change it. I'll probably make it clash. I think I actually make it clash with the end plate on the rafter when I was playing around with this. So here, yeah, go in and change the figure here. Again, this is some of the options that are available in the set out. It does depend on what the engineer has told you to do, where to put them, or what's come from the design program for the cold rolled spec. I have had that happen where someone's put the purlin right on top of the end plate on the rafter. It's caused all kinds of problems. But the idea was just to say that it moves. It does move up and down, and obviously it will change the angle of the stay because obviously the rafter haunch is getting deeper there, so it's changing all that. So I'm just going to move that back up slightly, move it away from the end plate on the rafter. And the important thing is I'm actually altering this in another macro, but it's actually affecting obviously the macro that we've created as an additional tool. Similarly, this macro can be copied as well, as I showed you with the other ones, even though we've got it in a situation where it's obviously got stays coming down into the haunch. I can actually copy it up and I can use the same tool. So again, for those of you not familiar with copying joints in advanced serial, you either pick an element of the joint or you pick the connection dialog grey box that's around the edge to actually copy it. So if you select that, then follow the prompts again. Now here we'll just skip the bit where it says about the haunch, and it will just revert back to putting a standard joint detail in there. So even though we copied it from one that had a haunch in it with stays going down into haunch, it reset the joint. So we did copy it up. Obviously, if we want to turn the stays back on, we would just go in and turn them back on, and they'll go back into the bottom of the beam this time. Similarly, you can use joint copy in a group, I think. Joint copy multiple is other options as well. Some people like to copy joints in a group. I don't always do that. Sometimes find it's because with roofs you can have obviously rafters that have got stays on, rafters that haven't got stays on. When they sort of cross the purlins, it does really depend on the cold roll design being applied. So here I'm doing a multiple option here, so select both the inputs as required, follow the prompts basically at the bottom on the command line. So with that in place, we can see that we've now applied those two sort of a singular and double joint to a standard sort of arrangement in the system without having to use two different joints. They're actually just, we combined them into one joint functionality, which I think is a bit easier for the user to find and understand. They just read the command line prompts that come up. So the other joint we looked at was the non-continuous joint as well. Obviously, sometimes where purlins rails are inset from the side of a column or inset in the roof, there's a non-continuous arrangement required. This joint hadn't been looked at for quite a while. There was quite a number of comments made about the previous joint from users, so we picked up upon those. We've gone in and tried to create our own version of this and applied it in the system. Obviously, it's a singular operation because it's a non-continuous joint. I think we addressed things like the stay plates they always end up clashing with the stay itself. They weren't being positioned correctly. But again, it's a very simple operation. You pick the column and then pick the incoming beam, in this case the purlin or the rail. It applies the joint to a standard detail that's stored in a library. You can untick it and change it to a catalog entry. Also, you can change the default if you want to by ticking the default box there. So if you wanted one to always have the stay on, you can actually turn it on and set that as your default. So just because we're providing you with one doesn't mean that you can't change it and you can't create your own as well. So this should work. It should give you the standard bolt fittings, bolt centers. You can go in and adjust stay plates. I know people tend to make their own stay plates and they tend to make them their own particular size depending on what they're doing. I think where I worked they were always 80 by 80s, but by 10, but some other people might make them 90 by 90. So again, you just come in and adjust this. You can change the bolt arrangements if you so wish, the bolt types. All this very similar sort of functionality that you would see inside a standard macro available inside Advanced Steel, and obviously you can create your own library entries. So that's pretty much the two different joint types that we have inside the system that we use and we have created, and they're currently updated with I think the 3 suppliers at the top that we said. Their data is available for those joints as well as all the normal Advanced Steel joints available inside the system. So one of the other things I just wanted to mention also with the PowerPack is the Structure Designer. You can actually add different purlin ranges into this. For 2020, we actually linked this with the 3 suppliers that we've added into the system. We've added it in via the Structure Designer. So you'll get a default structure come in, but you can actually set that to use a particular supplier. It doesn't have to be, it can be a Medtech or, a different supplier if you wanted. Albion, one of the ones that's in the core system. We did actually link it with the 3 suppliers that we'd actually created in the system, which we're obviously allowed to do. So we did that, we added it in, and the Structure Designer just gives you an option to create an overall portal frame interactively, and you can set up some template models in there to use. I think I did do a presentation on that last year, so there should be a video or webinar out on I think it's on our Graitec Advantages page now. I think we did it for the BIM conference we did last year. So again, there's a little option there to allow the users to add in their own system. It's done via the GUI mechanism. Those of you familiar with Advanced Steel will know there's the GUI allowed sections table. You should be able to go in there, find an example, and you should be able to add in what you need. The other thing I want to talk about is we found some limitations with some of the anti-sag arrangements that were available within core Advanced Steel. So what we did is we created some workarounds, I suppose is the proper term, but what we did is we used a custom connection to enable us to add some of these features in and get around the issues being caused by misalignment between the two by turning off certain elements in those joints when we apply them, but then using a custom connection to provide the sort of bracing at the eaves level and the brace cleat, etc., to maintain the alignment between the systems due to obviously something that couldn't be fixed within the core joint because that's obviously controlled by Autodesk. So at this point, this is what we actually did. We created these templates. These are now deployed with the PowerPack. You get them. We made them available to everyone, and we've done them for the suppliers that we need to do them for, which is obviously the 3 suppliers that we worked with. We explained to them the reasons why we were doing this. So I'm just going to walk through the application of those very quickly. So obviously another sort of test model scenario. You can see that I've applied a joint in there. I'm just going to talk through actually applying the actual anti-sag macro, how you actually apply that. So obviously this is available inside Advanced Steel. This is not a Graitec joint. This is a standard Advanced Steel joint again. So you would actually pick one that you required. So in this case, I'm going to pick a side anti-sag. So again, you pick some supporting columns. That's the first thing you do. You follow the prompts for that. Then you pick the various purlins that you, or rails in this case, that you wish to select. If you want to connect it to the eaves beam, you can connect it. If you don't have to go up to the eaves beams. I know some people don't do that nowadays. It depends on the system that's being used. I know I trained some people a couple of years ago. They said, well, we don't always do that now. We don't have to do that or something's changing the design scheme. So the idea was you put that in place and that gave you a good foundation. And then similarly, you could do a roof system, which is a different macro from Advanced Steel. Again, following the same sort of criteria, just pick the supporting columns, rafters, and then to pick the purlins. Now, the important thing to do is not actually make the connection to the eaves beam, so we turn that bit off. So we didn't select that. And that was because there was a little error in the macro there that caused a misalignment between the two systems. But obviously people still need to put in probably the eaves brace to restrain it, to stop it sort of turning over. So what we did is we then went off and created a custom connection to get around that. And we actually used two to do this. So custom connection is a standard feature again of Advanced Steel. It's not something we developed. It's a tool that's available inside Advanced Steel. In my opinion, very underused by people. Don't always seem to see the benefit of it. You can actually create macros using other macros also embedded inside it, and also create things from scratch. So here I'm going to pick one just to put the eaves cleat on. And to be honest, I stayed in the wireframe element because it was just easier to see the points I wanted. I'm a bit old school as well, so I tend to do that. So here I'm picking actually the edge of the eaves, sort of the strut cleat as the reference point. You'll see it puts a little node in there and it brings the cleat in, it adds the bolts in, etc. And it just puts a little blue dialog box around it. If you allow modification, it allows you to alter that or interact with it better. So I tend to just tick that. And similarly, we did another one to actually do the stay coming down the eaves strut, sort of from the last purlin to the eaves beam. So here we can see we've built a model. There's one for each obviously size section range in the system because they all have their own spacings and centers, etc. So we pick the purlin, and then we're going to pick the actual eaves beam cleat itself down there and apply that. So it's, you probably pick the purlin, you pick the anti-sag bar, and then the eaves beam. You may find you'll have to adjust it, but again, if you allow modification, you can actually just come in and pick up the grip on the end, and you should find a reference point there, which we've put the hole in place already to actually drag that to it. Sometimes the bolt doesn't always come with it. I've found that when we've done that, so we just sort of go back and grab that as well in a minute. At the top end, it should remain in place because that's the rotation point. So we're just going to go back here and just drag the bolt. So again, you just use the grips to do this, and because you've got a reference point. And I think we did a few little tricks, like extend the grip length of the bolt so that it didn't clash through the hole. The hole was already created by the other element. Also, it puts in a square hole in the actual bottom there of the. Some people use square holes when they're punching for purlins rather than round holes, depending on the stay system, the anti-sag bar system. Again, obviously we've used it all and we changed that to 2 actually, because obviously so we could get an extra bolt actually just for bolting the cleat on the other side, so you wouldn't be short on your bolts list. So this is just a way that we found it was easier to get around stuff. We've connected it all together as well, so all the elements come out on an assembly drawing for a strut. So obviously you send that to the supplier, they normally know all the bits they need to make. They don't tend to ask for individual part drawings, they just want like the overall assembly. We just changed it to shop so that it pulled it all together. This also, you can actually use this joint elsewhere. So I obviously did it at one roof angle, and I will show it at a different roof angle in a minute. And what we've done there is we maintain the alignment, and that was the issue. It was moving it over very slightly, wasn't keeping it in the right alignment when you went over the roof, so you'd have an offset, and when you try to go right over the building, the two bits didn't line up. The system needs to line up all the way over the building. Obviously that can be copied as well. You can copy it to the other side of the system using joint copy. So here we've got a different portal frame set to a 30-degree roof angle. I just sort of tried quite a steep one just to see if I could apply the same tool using the same methodology. So obviously the sag system's already in place. Didn't want to go through that bit again, but I'm going to go back, I think, to my custom connection, pick my particular type of custom connection, and apply that. So again, I put the cleat in, obviously select the eaves beam. That's the primary member. Obviously I'm using the edge of this cleat as a reference because it shouldn't change. Again, it puts the cleats in, puts the bolts in, the holes, etc., the various slots in the required. And then I'm going to go back and put the stay in. Now remember that the stay is going to be completely different angle. So again, I'm going to use the purlin and sag bar, etc. And then I'm going to pick on the eaves brace cleat, and the reason for doing that was to make the connection between the three elements. Now obviously it's come in at the angle, but it's obviously a bit short, which is what I said before. So you can if you grab the node on the end of the system line, which is what I'm doing, so you need to tick allow modification to do this. If you don't do that, it won't work. It'll just stay where it is. If you just hover over the grip, it'll pick it up and just drag the grip point down. And again, there should be a hole, reference hole that you can put it into, so you just snap it to that. Obviously the bolt tends to stay where it is, so just move that. And the beauty of this is you just do it once actually, and obviously if you've got to do this across the building, you can actually then use joint copy and copy it across the building, and it'll stay, it'll maintain this. So it was just something additional that we thought we would do to try and ease some of the issues that we saw in the present tools that existed inside the system. Obviously that's put a little cutout in as well, because in that particular one there's a notch, obviously, so it misses the bottom lip edge on the C section, oh sorry, on the Z section. So I'm just going to copy this across to the next bay actually. So just doing a joint copy. So because it's a joint, you can copy it. Or you can use the other tools here. Those familiar people using advanced steel will obviously be familiar with the different joint copy options available inside the system. So I'm just going to choose a singular copy. So first of all, I'm going to copy this across. So I'm not inserting it from the template. I'm actually just using following the prompts again, picking the beam, picking the reference point, and I'll apply it. And then similarly, I'm going to do the same thing with the stay that I bought in as originally as a custom connection. I then altered it to what I needed. I'm now going to follow the prompts again, selecting the purlin, the sag bar, and the cleat, and I'm actually going to apply it into this situation. So once I've got it in once, I've just tweaked it to where it needs to be, then I can copy it along the building. So the next area I wanted to have a look at is obviously you've possibly gone off and created all your model and stuff, and bill of materials always ends up being, people ask, can you get a list of cold rolled? Well, the answer is yes, you can. For some suppliers, we have created dedicated lists. There is a standard cold rolled list available inside Advanced Steel as well, but some suppliers asked us to create a dedicated list for them listing their products. So you will find it under the bill of material templates. BOM templates palette, it should be added under there. You should see a button and you should be able to select it and run it. I'm just going to talk through the process of that in this little video that's in here as well. So I've just created a little video for this. So this is the templates palette that's used to create bill of materials. Obviously we've got this particular supplier here. They've got their own tab and then they've got that there. Now, if you were to press that, it would actually run the bill of materials for absolutely everything on the fly from the model. So you need to use the select cold rolled object filter that's available under the tools. Under the standard advanced steel palette, you can actually select all the cold rolled elements. The system's set up to do that for the UK. So obviously we've added in this particular supplier system into that, so that's in this case Thomas Panels. So with all the objects highlighted, you can then go and press the button and it will actually go off and create the bill of material on the fly, creating an extract on the fly, so to speak. You can see the bar generating down in the bottom right there. And that opens the BOM editor. So this is all standard functionality. This is not functionality we've created. We've just created the template that presents with this particular supplier. So obviously you can store that, you can export it to an Excel, you can export it to a PDF, etc. And it should list all the components that are relative to cold rolled. And the trick to that is use the select cold rolled objects from the tools palette. The other element I wanted to talk about is obviously the drawing output. People obviously tend to do detail sheets for cold rolled. So for the 3 suppliers I think we've put in, we've actually added them into the system. So we've added in some detailing sheets. Again, we've created a prototype file for them so you get their border. We've also, with some suppliers, created a specific drawing style adjustment, and also there's a process button for doing this. This is all added in the background via the drawing style system under the UK styles provided by Graitec as part of the PowerPack. So again, this is standard functionality. All we've done is added in the supplier system to it. So I'm just going to walk through that in this video, where to find it. Just show you the process here. So obviously those of you familiar with creating drawings from advanced steel know that you can run a drawing process. You can also create them from a style. But here we've got standard, and obviously we've got UK styles. So you have the standard UK styles, but also you have a user section and a Graitec part that gets added in by the PowerPack. So if we pick the Graitec one, we can see it changes, and you can see that there's some suppliers listed under there. This is obviously a Thomas Panels model. You don't need, in this case, to actually filter anything. It will know that there is a Thomas Panels section. There is a filter set in the background of the drawing process. So you just come in, select it. It will just run everything in the model. It will filter out the bits that it doesn't need to do that. There's a secondary filter. So you don't actually need to do anything. You just need to press the button and let it process. Now, obviously, depending, as people know, it takes a few minutes for it to do this in the background. So it will go off and it's looking for the prototype file. It's looking for the particular drawing style relative to the particular element. So it's using the various model roles that are applied when you apply using the macros. So it is important that you use things like the structural element macro, use the anti-sag macros, use the various purling cleat macros, etc. So it applies all the right model roles that then filter into the drawing style system, and then more importantly the drawing process system to actually control the output and how the drawing is processed and presented. When you do this, typically in advanced steel, it obviously creates all the folder structure in the background, and it whizzes away in the background creating all these drawings for you. As I said, it does take a few minutes. I didn't actually chop this. I just sort of left it alone, let it run in. So I thought, well, I'll just see how long it took to do this. And again, this depends on your machine, the size of your model, etc. But the important thing is you should get all the drawings out of the system. And all we've done is extended the standard functionality within advanced steel, and we've just added in these extra options to enable our users who are using this via the PowerPack, they get this installed, and obviously enables them to give what they want with obviously the bill of material to their supplier. So we can just a quick look there to obviously it's prefixed it with in this case this supplier reference at the top on the naming. Obviously SR means side rail, so it's obviously picked up a prefix when we've numbered the model. Obviously there's the paper size there. Obviously it generates all the other files that you need as well for the document management system, the UPD files, the DB files. So obviously that's just whizzing away in the background. It does take a few minutes, as I said. Should be finished in a second. This is something that people just do. Yeah, you have to do it. I think even if I'll be honest, some other suppliers we do have CAMWIN, I do tend to do this anyway. So it's done those. Obviously, it automatically saves. I do tend to press the save button myself personally, force of habit. And then I'll just go and look at one of those just to show you a drawing output. And this is the detail that is produced, obviously on the relative supplier's prototype file template, and obviously that's a standard sort of drawing process from it, and naming and labeling, etc. Title to the drawing. It's fairly simple sort of kind of operation. So that sort of ties it up from sort of start to finish, really, in my opinion. That's how we would sort of approach that. So that brings towards the end of sort of the main sort of body of the presentation today. Obviously the about cold rolled, but just remember we are here to help you. So we do have various roadmaps to sort of step people through. We find a lot of people, they sort of do the basic training and then we never hear from them again, and we reach out to them and they've had all kinds of problems. So please use your support. If you've got a support contract, Rob and Malik are really good at that, so they're always on the ball. They'll drag me in if I need to get dragged in. We do other things. We go out and customize people's system for them. We offer workshop days, total management of the system. We've worked out sort of what we consider are the 5 steps of success with using Advanced Steel. So please reach out to us if you need any additional services from us. We've got a few minutes, so probably haven't got long. If anybody had any questions, they can type them in the chat window. There is a questions box, I think, or anything that's going on. Or if you want to, you can just email me after today's presentation if you think of something or you want to ask or discuss something. I'm quite happy to answer that in due course. So we obviously are available here. So my email address is on the screen in front of you. So I'll just hold that for a second and see if anybody types anything in now. Okay, so that's a sort of brings to sort of an end today's presentation. So just like to say thanks to everyone for attending today and watching the presentation. I hope you found it informative. I expect a copy of this will get added to the Graitec Advanced Steel portal page that I mentioned earlier on. So please make sure you get a copy of the PDF before you leave today. Just click it and download it. And obviously, if you have any problems or have any questions, please reach out to me or my colleagues Rob and Alec, and I'm sure we'll be able to help you. So thank you very much for attending today.